Hi, my name is Maharaj. Today we are presenting to you our recent work, MorphTok, Morphologically Grounded Tokenization for Indic languages. This work is done in collaboration with NJ Karthika, Atul Singh, Devaraja Adiga, Smruti Bhate, Ganesh Ramakrishnan, Rohit Saluja, and Maunendra Sankar Desarkar. Popular tokenization algorithm like Byte-pair encoding works in a bottom-up approach, initially starting out with Unicode characters and iteratively merging in a greedy manner. These merges are based on raw frequency counts. This often leads to over-segmentation for underrepresented data. Segments are not morphologically correct and leads to dependent vowels occurring as a separate token for languages following syllabic script, which is commonly seen for Indic languages. In this work, we address two issues. First, of segments not being morphologically correct, especially for Indic languages, and second, dependent vowels occurring as a separate token. To address these issues, we propose two approaches, MorphTok and Constrained BPE. To enable meaningful segmentation, we manually created lookup tables for two of the prominent Indian languages, Hindi and Marathi. To handle the dependent vowels of a syllabic-based script, we introduced constraint in an existing tokenization algorithm. In MorphTok, we introduce meaningful segments during pre-tokenization stage. These meaningful segments are introduced using a lookup table. The lookup table contains word and its corresponding morphologically grounded segments. For example, the Hindi word Vidyalaya meaning school contains two splits or segments, Vidya meaning knowledge and Ale meaning abode or place. During pre-tokenization stage, we replace words present in the lookup with its corresponding segments followed by the standard BPE algorithm. By introducing linguistically meaningful segments before applying BP, MorphTok produces tokens that are more interpretable and can help in reducing the fragmentation often caused by the BP algorithm. Putting it more formally, we have a lookup table L. We apply pre-tokenization on tokenizer training corpus C. In pre-tokenization stage, we explore two ways for creating lookups. First, manually created lookup, and second, model-based method. In model-based method, we fine-tune pre-trained model Byte-defy using manually created dataset. Thereafter, the model is used to generate morphologically grounded segments for the unique words present in the corpus C. After the pre-tokenization stage, we apply BP on the pre-tokenized corpus C-. We evaluate the performance of tokenization algorithm using extrinsic and post-hoc human evaluation. For extrinsic evaluation, we evaluate the performance on two downstream tasks, machine translation and language modeling. We measure machine translation performance using CSRF and Comet metric. For language modeling tasks, we compare perplexity and loss scores on a holdout set. For post-hoc evaluation, we perform human evaluation on the segmentations and empty generation. To measure the quality of segmentation, we introduce EvalTalk metric, a scoring criteria for human evaluators. The segmentation quality are scored in the range of 1 to 4. Score of 1 for segmentation where none of the token segments are morphologically correct and neither preserve the semantics of the original word. A score of 4 if all the tokens are morphologically and semantically correct. We measure the empty generation and using XSTS metric. In machine translation tasks, we observe consistent improvement compared to BP in terms of comment scores in both 16K and 32K vocabulary size for both Hindi to Marathi and Marathi to Hindi translation directions. In language modeling tasks, we observe lookup plus BP performs better than BP with lower perplexity and lower loss scores, showing that pre-tokenization stage help in better language modeling. In post-hoc human evaluation, we observe lookup plus BP have higher EvalTalk score than BP. For translation quality in Hindi to Marathi, lookup plus BP have higher scores than BP. For Marathi to Hindi, we observe slightly lower scores for lookup plus BP. Overall, our experiment suggests that introducing grounded segmentation during pre-tokenization stage improves segmentation quality, also with an improvement in downstream tasks. In our second approach, that is constrained BP, we address the issue of dependent vowels occurring as a single token. As we know, Indic languages follow syllabic writing system, unlike Latin script, which are alphabetic. The vowels in syllabic system can be grouped into dependent and independent, where dependent characters occur as a cohesive unit with preceding consonant in general. However, existing tokenization algorithm does not consider this. So why does handling dependent vowels matter? We observed that for 8K vocabulary size, around 10% of the merges correspond to that of dependent vowels in the BPE algorithm. This is wasteful. So in CBP algorithm, we ensure that dependent vowels do not occur as a single token. Formally, in CBP algorithm, we modify the standard BPE algorithm by initializing vocabulary with dependent vowels attached to preceding Unicode character and follow the similar merging strategy as the BPE algorithm. We evaluate CBP by intrinsic and extrinsic evaluation method. CBP have lower fertility score compared to BP for both Hindi and Marathi. In machine translation tasks, we observed CBP leads to comparable result to BP in terms of CSRF2 and COMET scores. In some cases, CBP is shown to yield higher scores than BP. In summary, we have created morphologically grounded dataset or lookups for Hindi and Marathi. We have introduced meaningful segments during pre-tokenization stage and have shown that it helps in a better language modeling compared to an BPE algorithm. The model-based word segmentation can potentially be used as a human-in-loop approach for a faster lookup creation. We have shown that constraining a dependent vowels handles an obvious merges and have also led to a reduction in a fertility score. Our future work includes the expansion of lookup for other Indian languages. As an acknowledgement, we would like to thank the data annotators and language experts for creation and verification of lookup. Huge thanks to human evaluators for assessment of translation performance and to anonymous reviewers for valuable insights and suggestions. Thank you.